I'm Peter Batty, CRO at SSP Innovations, and I'm talking today about how GeoConvergence can transform the quality of geospatial infrastructure data, which is generally very poor today. Having accurate geospatial data records about network infrastructure is a crucial foundation for reliably and safely delivering electricity, communications, gas and water, and it's becoming even more important as we try to run those networks in a smarter way. The main data quality challenge I want to focus on is data currency. The as-built data backlog at most infrastructure companies is measured in weeks or months. That's the time between equipment being installed in the field and when there's a record of it in the company's GIS. This is because it's too complex and time-consuming for the people installing the equipment to record the required information about it. That's done by someone else at a later date. We need data capture to be much simpler and more automated so anyone can do it. There are technologies being applied in other industries that might help us solve this problem. This video shows how Tesla Autopilot automatically recognizes and spatially locates objects like stop signs, traffic signs and other cars many times a second. Machine learning-based image recognition is available in many consumer and enterprise apps, from tagging people on Facebook to being able to recognize photos by content on Amazon. Models can be easily trained to recognize new types of object. Augmented reality is growing too, from massively popular games like Pokemon Go to interior design applications from companies like IKEA. The ability of AR applications to intelligently build accurate models of the world in real time is increasing all the time. And finally, I'll mention the idea of reality capture, which overlaps with the previous areas and involves capturing accurate 3D data about the world with a variety of capture devices, from Google Street View cars on the high end to smartphones on the low end. I've recently been working on a prototype smartphone app to see how we can apply these sort of technologies to address the data quality challenges of infrastructure companies, as I talked about before. Let me show you our work in progress on what we're calling automated field sourcing. So I'm pointing my iPhone at an asset here, and the app recognizes it as a manhole using image recognition. Now if I point over here, it recognizes that this is a parking meter. Now when I move around the other side, it reads the ID number and displays that at the top. If I tap on the screen, then it adds a point and a label in augmented reality space. Now if I move to the manhole down here, I can tap on the screen again, and you see a label showing that it's a manhole. We can go over to the second manhole here, do the same thing. And now let's walk back over towards the pole here. And you can see that we're now recognizing the pole through image recognition. When we get closer, we can see the label. And so we can add the information about the pole and its pole number. Now we'll walk back over to where we started. And you'll be able to see there that the points and labels have retained their position. And so one of the advantages of using augmented reality technology is that it gives you more local accuracy than alternatives like GPS. Now I'll show the concept of adding linear features. Here I'm just using the iOS Measure app, but this will be integrated into the prototype very shortly. So you can see the distance that we've measured there. The line holds its location in the space just as it did with the points. And so this will be integrated with the capture of points quite shortly. So our initial approach on this application is intentionally semi-automated to build user trust and enable us to build better recognition models over time. Shortly we'll be adding barcode scanning and voice interaction for capturing more information. In future we see a transition to fully automated data capture as the field technician works without them having to do anything at all. Data will be captured by wearable devices like smart glasses or helmet-mounted devices. Another key development coming over the next few years is what many people call the AR cloud, a detailed point cloud of the world, which will enable much more accuracy than we can get from GPS using so-called visual positioning systems. I think that the next few years will see us moving rapidly towards the notion of large-scale digital twins, providing increasingly accurate, near real-time information on specific aspects of the physical world, like a utility or communications network. Realizing this sort of digital twin fits very much with the theme of GeoConvergence, as the technologies needed are being developed across a wide range of industries outside the traditional geospatial market. It's a very interesting time to be in the geo industry.